Hey guys, in this video we'll be covering functions, specifically basic syntax for declaring them, duck typing and broadcasting, and we'll also look at how to use packages in Julia. Okay, so coming to functions, Julia gives us a few different ways of writing functions. The first and most common one uses the two keywords function and end. So writing a function would be something like function func of a, do something, and then end, which denotes the end of the function. And then a calling function would be something similar. The second way is writing it in somewhat a mathematical format. It goes like func of a equals println a into 2, and then func of 3 is 6. And the third way is known as an anonymous function. It goes something like fun equals a hyphen arrow mark println a part 2. And then if you do fun of 3, it gives 6. And then there's an interesting feature which Julia supports. It's known as duck typing. And there's something known as a duck test, which goes like this. If it walks like a duck and it quacks like a duck, that must be a duck. Duck typing is an application of this duck test, which checks if an object is suitable for a particular operation. Suppose I write a function power of a, which does e to the power 2 and then says so I can do power of 2, which gives 2. But also I can do power of str. And it still works because the power operation is defined for both 2 and str. So here, Julia automatically decides the input type and does the related operation. So we say that Julia supports duck typing. Functions in Julia are mainly divided into two categories, the mutating functions and the non-mutating functions. Mutating functions are those which alter their inputs and non-mutating do not. By convention, mutating functions are followed by an exclamatory symbol which is called the bang, while non-mutating are not. Let's look at an example. Suppose I have an array 1, 2, 3. There's a function called sort in Julia. Okay, wait. Let me take it as arr equals 536. There's a function called sort in Julia which sorts the array. And now if I check arr, it's still unsorted. So here sort was a non-mutating function. Suppose I call the mutating version of it. It still sorts, and if I check arr, it's been reflected back. So here this is called sort and this is called sort bang. Remember that this representation is just a convention and not strict, need not be strictly followed. In case you're writing your own mutating function, remember that data types like strings, tuples, and float, these are all non-mutating data types, which means you can't change the values. Now don't get confused. When I said ends and floats are non-mutable, what I meant was that their values can be changed. Suppose I have say a equal to 5. I can change what a represents, but I can't change the value 5. But I can make a equal to 10. So in this way, even ends are non-mutating. Let's write our power function again. Function power of e to the power 2, and suppose we have an array 1, 2, 3. Now what if I wanted to apply this operation to each and every element in this array arr? Would doing something like power of arr fix it? Nope, it's an error. This would just try to square the entire array, and there's nothing known as square of array anywhere. Julia fixes this with the help of something known as a broadcast. Yeah, the name should give you some idea. Do something to everyone over there. And how it works is by using the syntax power dot of arr. and it just squares each and everything. It just applies the same operation to every element of the array. Okay, so now suppose I had to do something like x bar 2 plus 2 into 10 for all of the elements in array. It would be something like power dot of arr dot plus 2 dot into 10, which should give us the required answer. Oh wait, I forgot to put the braces. My bad. Just like that, and here it would be. Yep, that's the required answer. Also, there's something known as multiple dispatch in Julia, which is almost similar to what we call function overloading in C. But we won't be needing that in our SMP, so I'll skip that for now. I'll be sharing resources later. You can look at them if you're interested. Next, coming to packages. Packages are just code written by someone which deals with a specific issue or topic and is made easily available to everyone. They help in eliminating what is called reinventing the wheel, or to simply put it, they make our job easier. Julia has around 2000 registered packages, and a list of them can be found over here. Using packages in Julia is pretty simple. The first time you use a package on a given Julia installation, you need to use the package manager to explicitly add it. PKG, that's the package manager. And how do you use this package manager? Using PKG. Yeah, that's it. I'll just add a sample package. Yeah, pkg.add of the package name. That's how you add a package to your installation. And remember, this has to be done only once per installation. I had done this before, so it's already updating and no changes. Now, how do you use this package? Same as the package manager, using example. The source code of this can be found on GitHub. You can search through this link and you'll find it over there. The example package has two functions. One is hello and the other is domath. So I can just call them normally now. Hello of hey. And just says hello hey. And domath of 5 would say 5 by 5. You can look at the source code to know why it's doing that. Okay guys, so that's it for this video. Hope it wasn't boring. If you have any doubts, you can post them on Slack or message any of the mentors. Thank you.